This is the fourth video in the series for CISC 132, Routing Protocols and Concepts. In the first video, we talked about default gateways and how to take information from my LAN and send them out to the internet or off my LAN. In video 2, we talked about how to connect our LANs together to other LANs using wide area connections on our serial ports. And on our third video, we talked about static routing and how to tell our routers about distant networks. This video is about dynamic routing. Specifically, we're going to use RIP version 2. This is a good time to discuss the difference between static and dynamic routing. With static routing, we were basically telling our routers what ports to send out traffic to other networks. In dynamic routing, we do exactly the opposite. Instead of telling our routers where other networks are, we just configure our routers to tell other routers what networks we're directly connected to and which ones we want to advertise. So in our example, our Granite City campus LAN 1 and LAN 2 need to be connected to the Belleville and Redbud campus LANs. So with static routes, we told the Granite City campus how to get to the Belleville LAN and how to get to the Redbud LAN. What we're going to do in dynamic routing is we're going to configure the Granite City campus router to advertise to the other routers about the Granite City LAN 2 and LAN 1. And then the Belleville campus and Redbud campus will do the same for us. They'll tell us about the networks that they're directly connected to. Now, this has some big advantages. Probably the biggest advantage is that with dynamic routing protocols, we can self-heal the network and find ways around parts of the network that go down. Now, in our example, we don't really have a loop that we could go a different route. But with the static route, once I say to go out one interface and that interface goes down, the network has no way of sending the traffic any other way. But if I did have several ways of getting to the same place, and one of those ways went down, and that was the way that the static route was told to send traffic, dynamic routing would say, go a different way. So there's a big upside to dynamic routing, other than the fact also too that with static routing we have to go to every router and put in every remote network. So dynamic routing certainly has its upsides, especially with large networks. Small networks, you don't really need dynamic routing. The downside of dynamic routing, of course, is that in order for this information to get from router to router, we actually have to send out small packets every once in a while to tell the other routers about these routes. So that eats up a little bandwidth. Plus, there's always some processing overhead once you get those informations and need to create a new routing table. So take it for what it's worth. But in larger networks, dynamic routing is by far the best way to go. Now, in our example, we've got 4 LANs that are connected by 3 routers. So what I'm going to do is I'm going to start with the Granite City router, and there's not a whole lot to it. With RIP, we just have to say router RIP, and this will turn on the dynamic protocol RIP. I then have to tell it what networks I want advertised. And in this case, this one network statement will cover all 3 interfaces. Now we'll go to the Belleville campus and do the same there. Turn on router RIP, give it the network, and we'll do the same in Redbud. Now, we're going to find out here real soon that this doesn't actually work. RIP version 1 in this situation does not work. I don't want to spend a whole lot of time on this, but let's look at the Belleville router, and we'll do a show IP route. And notice we're not getting any routes here. We're not getting anything at all. And the reason is, and I'm not going to show you this, but you can do this yourself. If we were to go over here in simulation mode, and we were to look at these packets that are being sent, there's no subnet mask that's actually being sent with these updates. So the router's disposing them, saying, well, look, I already have a 192.168 network here. You guys don't really know what you're talking about. So it's very untrustworthy. So what we really need to do is change our RIP version to version 2. And I can do that by typing in version 2. But if I do a show IP protocol, I can also see here that I'm sending version 2 and receiving version 2. And here's the networks that I'm talking about. And these are all the interfaces that belong to that. Now if I do a show IP route, now I'm starting to pick up some of those RIP updates. And here we go. So now we can ping all the way across the network. And the reason RIP version 1 didn't work is because we didn't send the subnet mask. And remember, RIP version 1 is classful, RIP version 2 is classless. So in summary, this is why we want to use dynamic routing. It makes it a lot easier to configure, and it's a little more forgiving than static routing. So if you want to, go ahead and configure all those routers, and then we should be able to ping all the way across our network without too much problem. But you have to do it right, you know. There we go. Okay, well, the next video will be probably EIGRP, since that's Cisco's proprietary networking protocol. And I'll probably get that out to you pretty soon.